All right, good morning, guys. Tomorrow is review day for our quiz. It'll be over the first three sections. We're spending today going back over or going through some more stuff for 3-3. So if you're going to be gone tomorrow for some reason, let me know. I'll get you the review ahead of time so that you can have that. Okay. And then Thursday is our next quiz. So far in chapter 3, we've graphed for first section, okay? Then we talked about slope last week. And then yesterday we started talking about writing a linear equation. And today we're going to continue talking about writing linear equations. But we're going to talk about doing that with parallel and perpendicular lines. So the first thing that we're going to go through is kind of talk about what makes two lines parallel versus perpendicular, and then eventually we will get into where we have to decide what is an equation that would be parallel or perpendicular to a given equation and goes through a particular point. Let's start with parallel first. These are both words that you should be pretty familiar with, okay? Parallel means we have two lines that never intersect. In order for those two lines to never intersect, what would have to be, we talked about slope last week, what would be true about the slope in these two equations? They'd be the same, yeah. The two lines must have the same slope. Hey, if one goes up 3/5, the other one's got to go up 3/5. And that's how we know they would never cross. We can also say that two vertical lines are parallel. The reason why that's kind of like its own statement is because a vertical line doesn't really have a slope. It's undefined. And if I have another vertical line, it would also be undefined. So even though it doesn't have a slope, any vertical line would be parallel to another vertical line. So we can't say they have the same slope. They're both an undefined slope. But they would still be parallel. Okay. Horizontal lines would be the same way, but a horizontal line has a slope of 0. So then we could say, yes, they do have the same slope. They both have a slope of 0. Okay, so parallel is pretty straightforward. Those two lines will continue on. They're never going to cross one another. So we say that they are parallel. Perpendicular if two lines are perpendicular to one another, if I draw this line on here, how do I know that another line is perpendicular to it? If I were to draw a line like this, would it be perpendicular? If we knew what the slope was, yes. What'd you say? Has to make a 90-degree angle. Good. Okay. If these two are perpendicular, then the line where they cross, or the point where they cross, I should say, should make a 90-degree angle. Okay. So what we would say here is two lines that intersect at a 90-degree angle. Okay. Now, and this is kind of where Hudson was going. If we talk about their slopes, they are opposite of one another, and they are also reciprocals of one another. So we say that they are opposite reciprocals. So for instance, if I said one of them had a slope of 3/7, the other one would have to have a slope of -7/3. So we flip it over and we switch the sign. One's got to be positive, one's got to be negative, and the two slopes are reciprocals as well. Okay. So you got to do both things, opposite and reciprocal. So the saying that I always use here to kind of remember this is we have to flip the switch. We flip it over and we switch the sign. Okay, so whenever we talk about perpendicular, because you're going to have a situation in some today where they're going to give us the slope of one equation, and they're going to ask us to write an equation of the slope of another equation, and so we're going to have to flip the switch on this. So if I already know this slope, then I just flip it over and switch the sign, and that would be my new slope. So they may not always give us both of those. I also will tell you this because sometimes this is mentioned. The two slopes have a product of -1. If I multiply these two together, 3/7 times -7/3, they should multiply to get a -1. Okay. That's not something that we use a ton, but it is something that sometimes gets mentioned. Like that is a question that you might see like on the ACT or something. And so if I multiplied those together, product means multiply, then they would multiply to equal -1. Okay, so it's just another fact that's true about all perpendicular slopes. Okay, and we're really not going to graph a lot today because we're not going to graph this and then we're not going to look at it and say, oh, do they form a 90-degree angle or not? So we don't necessarily have to look at the angle and measure the angle or anything like that. We're really just focusing on the slopes of those two. Okay, on these, we're going to see some questions that are going to ask us, are these parallel? Are they perpendicular? Or is it neither one of these? Okay, so on this one here, are these two parallel to one another? Do they have the same slope? Well, right now it's in y equals mx plus b form, right? So what's the slope of this one? 1/3. What's the slope of this one? 3. Okay, are they parallel? Do they have the same slope? No. Okay. Are they perpendicular? So it's flipped, right? 1/3 and 3. 3 is thought of as 3/1. But not only do they have to be reciprocals, what else do they have to be? They have to be opposites, okay? These two are not opposites. So this would be an example of neither one. Okay, if I said y equals 1/3 x plus 9 and y equals 1/3 x minus 8, these two would be parallel to one another because they both have a slope of 1/3. Okay. We don't really care about what the y-intercept is for what we're doing here. All we care about is what the slope is. We look at the two slopes. I don't even really care about the y-intercepts here. Here my slope is 3/4. Here my slope is -4/3. Okay, so they are definitely not the same. We flip it over, and one's positive and one's negative. So on this one, we've flipped the switch, and so we would say that these two are perpendicular. So you'll have a few where you just have to kind of decide, are these two parallel? Are they perpendicular? And if they're not either one, then we would say neither. So just looking at your slopes. Okay. If it's in slope-intercept form, life's pretty good, right? Trying to determine the slope is pretty easy. But unfortunately, it won't always be in slope-intercept form. Because the other form of an equation that we have excuse me, is standard form, okay? And we've talked about this over and over again, but when these two are in standard form, the numbers in the equation mean nothing, really, okay? The 3, the 5, and the 4 here are just numbers. We call them the A, B, and C value. Same thing on bottom. 5, -3, and 2 are just numbers. So I can't just look at the equation and say, boom, there's my slope. Okay? And so that makes it a little bit more difficult, right? I have to decide if these two are parallel, perpendicular, or neither. And right now, I don't know what the slope is. When it's in slope-intercept form, piece of cake, because I know it's y equals mx plus b, and so I know my slope. So there's a couple different ways that you could do this, okay? One way to do it is to solve for y, okay? Now that's going to be the little bit harder way, and I'm going to show you a shortcut here in just a second, okay? If you forget the shortcut, you can always solve for y. So to solve for y here, we could subtract 3x. And then we could divide by 5. Okay, and the only thing that we're really concerned with, as we talked about before, what's my slope? But it takes a little bit to get there, right? And then we get some fractions and whatever, and not a big deal. We don't really care about our y-intercept so much. So the trick here is we call opposite of A over B. If you can remember that little formula, that will give me the slope right away. Because remember that this is my A value, my B value, and my C value. And we're not using the C value here. We're just using the A and B. So for this one here, my A is 3. So I would say the opposite of A, which is the opposite of 3, over 5. And it's a whole lot easier to find my slope than solving for y, right? I don't have to go through all that solving for y. I just can remember the opposite of A over B, and it's really, really quick to find my slope. So for the second one, do we really want to solve for y? I would say no, right? Unless you really have this burning desire to solve for y, right? Then why would we do that if we have this trick, have this shortcut of getting there, right? We're all about shortcuts. We love shortcuts. We had a shortcut here, okay? And so in this one here, my A value is 5, my B value is -3, my C value is 2, but we don't really care about the C value right now. So for the second equation, we're going to say the opposite of A is -5 over -3. Now here you just got to be careful because we have a negative and a negative, and two negatives make a positive. So this becomes 5 over 3, okay? A really quick and easy way to get our slope, if you can remember it. Okay, if you can't remember it, you can always solve for y. So here my slope is 5 over 3. Here my slope is -3 over 5. What would we say about these two slopes? They're perpendicular, okay? They are opposite and reciprocals. Okay, so that one's a little bit more work, only because we don't know what the slope is right from the start. Okay? You can't just look at the equation and say, yeah, these are parallel, perpendicular, or neither. But if you remember that trick, should be a piece of cake. Okay. 2 problems, and you're going to have a couple of these today on your assignment. And you really got to be able, you just have to go through and solve these out and write the equations kind of like we did yesterday. There's a little bit more involved here. So the directions are going to look something like this. Write an equation parallel, bless you, to the original and goes through to -6. Okay, so the original equation here is y equals -5x plus 3. Okay, and this is where we're going to kind of do what we did yesterday. I want to figure out what my slope is, and then we're going to write an equation that goes through that point with that slope. Philip. Yep, I'll let him know. Thanks. Ryler, you're supposed to go see Mr. Patton. You have time. Do you want to go now, or you want to wait till the end of the lesson? Okay. He didn't say anything about taking yourself. Okay, what's the slope of this equation? -5. Okay, so m is -5. And I'm going to tell you right now, one of the things that probably confuses or messes people up on this one more than anything else is, where do I use this 3? Well, you don't, okay? And so what I would say is just get rid of that 3, because a lot of people want to try to bring that 3 into the equation, and it's not needed, it's not used, okay? That is the y-intercept on my first equation. All I need out of this first equation is my slope, okay? So I'm just telling you right from the start, that's a thing that a lot of people try to use, and you are not using it at all. So that's why I just put a big X through it. And then we have a point. So we have a slope, and we have a point, and we're going to write the equation, and when we write the equation, we're going to put it in slope-intercept form, kind of like we did yesterday. And I think what we decided yesterday was putting it in point-slope form. We're just going to use that, unless you really want to use point-slope form. For the quiz tomorrow, or on Thursday, I will put up slope-intercept form, I'll put up slope formula, and I'll put up point-slope form, and I'll put up standard form. So I'll put up those 4 things, and I'll put it up for the review tomorrow as well. You'll just have to know how to use them, okay? And so we talked about this yesterday. This is my x, this is my y. Y equals mx plus b. The only thing we don't know is b. So we have to find out what our b value is. So we're going to plug -6 in for y, -5 for m, 2 for x, plus b. Add 10 to both sides, and I get b equals 4. So my final answer here is -5x plus 4. Okay, if I look at the 2 equations here, just to kind of double check what's going on here, this one has a -5, this one has a -5. So those 2 equations should have the same slope. If they don't have the same slope, something's wrong, right? The y-intercept will be different. They will cross the y-axis in a different spot, but they both better have the same slope because we want an equation that is parallel. Okay, so just kind of look at your equation at the end to make sure they have the same slope, and obviously, like we said, the y-intercept should be a little bit different. Okay, so that is one type of equation. Another one, very, very similar instructions here. Write an equation perpendicular to the original and goes through the point to -1. Okay, my original equation here. Y equals 1/3 x plus 6. My perpendicular slope would be what? Negative. Yeah, -3/1. And we could write it as -3/1. We don't necessarily have to put over 1. We could just say -3, okay? So that would be my perpendicular slope. We just flip the switch, right? Flip it over, switch your sign. And we also want it to go through the point to -1. Where is this 6 going to come into play? Nowhere. It doesn't, right? So what we talked about on the last one, just get rid of it, okay? Put a big X through it. Don't let it confuse you. If you're trying to think, where am I going to include that? It doesn't get included. It's not part of what we're trying to do here. All we need out of that first equation is our slope, okay? So just keep that in mind as you do these. And then everything else is going to be very, very similar to what we did, okay? So -1 equals -3 times 2 plus b. And then we're trying to get b by itself. And that'd be our equation. Okay. Kind of like we talked about in the last one, make sure your two slopes are opposite and reciprocal. So this one's 1/3, this one's -3. We don't really care too much about the y-intercepts. The y-intercepts are usually going to be different, okay, unless that's the intersection point. Those will usually be a little bit different. Okay, that's what we got for today. Just a continuation, but it would have been way too much to try to do what we did yesterday and what we did today because there's a lot of information from 3-3. So that's why we split it up into 2 days. All right, we are on the same page as yesterday. Going by 4, so start at 48, and then every fourth one. So then 52, 56, and so on. And then 84 at the end. Okay. You got some time here today to work. Make sure we're using it. Like I felt like lately we haven't been really using the class time that I've been giving you to work. Okay, so let's get out your books and let's. If you didn't get yesterday's done, you can work on yesterday's. You can work on today's. You should have some problems that you can work on. I will get answers posted tonight to all 3 days, so you can have those to check, and then tomorrow we'll work on our review.